You have a negative charge, Q, right there. Let's put it right there. It's negative. And we want to calculate the electric field at some point P of here, such that R, which is the distance from the charge, that's R, so that R is 0.3, 30 centimeter, which is the same thing as 0.3 meters. You must convert. And the charge Q is negative 3.0 microcoulomb. Okay, so we want to calculate the electric field at this point. Now, please remember that electric field is a what? It's a what? It's a vector quantity. So we're going to have to use vector analysis, and we're going to have to find the net field just like we found the net force. So I want to calculate the field right there. Okay? So since this charge is negative, which direction will the field point in? Which direction?
Inward.
Huh?
Inward. Inward.
Inward. This field will point towards the charge. There's my electric field. Okay? So to calculate the electric field, I will go through J, Q, over R squared. Very simple. 9.0 times 10 to the, that's a little bit too pale, 9 Newton meter square, Coulomb square. Times the charge, 3.0 times 10 to the negative 6. Once again, don't worry about the negative sign. We're just calculating the magnitude of this charge right now. Divided by 0.3 meter squared. And when you calculate this, you should get, let me see, 9 times 3 divided by 3 divided by 9. Up at the top times 10 to the 3, and at the bottom times 10 to the 4. 10 to the negative 4. No. 10 to the negative 2. I'm doing my little algebra. You can do it on the calculator. So this cancels that. So that's going to leave 3.0 times 10 to the 5. So this is my electric field. Right there. This is the magnitude of the electric field at that point. Know what you got?
Yeah.
You see how I got this?
Yeah.
What I did right here, I just made this 3 times 10 to the negative 1. And I just square my 3, I got 9. And I square my 10 to the negative 1, I got what? 10 to the negative 2. So that divided by that gives me my 3. 3 minus the negative 2 gives me 5. Done. Okay? So now, let's add a little twist to this. add a little twist. Let's say we put another charge right here. Let's make it positive. And this charge is 50 centimeters from this point. So let's call this R2. That's 50 centimeters. Okay? I want to calculate the electric field at this point. Due to both charges. I already have this, right? So if this is positive, the electric field at this point will point that way. So let's call this E2. All right? And let's call this Q2. Okay? So now, I need to calculate the electric field for Q2. This is my eraser. E2, K, Q2, over R2 square, 9.0 times 10 to the 9 Newton meter square, coulomb square, times the magnitude of this charge. Let's say this charge, the magnitude of this charge is 2.5 microcoulombs. So 2.5 times 10 to the negative 6. Divided by 0.5 meter square. Once again, that gives us 9.0 times 2.5 divided by 5.0 times 10 to the 3 at the top, 10 to the 2 at the bottom, and that gives us 4.5 times 10 to the 5 N over C. Okay? So E2, so we have E is equal to 3.0 times 10 to the 5, and E2 is equal to 4.5 times 10 to the 5. So what we have done here, we have found the magnitude of both fields. So now what we need to do is add them vectorially to get our net field at that point. Are you guys with me so far? Okay. So the next step is just to add these to get our net field. Can I erase this? No? Get another board.